Hello friends, myself Dr. Nandakumar Raubal from College of Engineering Ambadur is going to deal with numerical methods in mechanical engineering. So this is our 19th lecture. In previous lecture, we have seen numerical differentiation, then forward difference approximation of first derivative, then backward difference approximation of the first derivative, then centered difference approximation of the first derivative. Then we move to the second derivative, backward difference approximation of second derivative, and forward difference approximation of second derivative, and center difference approximation of second derivative. So now today we are going to discuss, or we are going to solve some of the numericals to find numerical differentiation of given function. So now first of all we have this function f of x is equal to sine x, and he is asking us to find out f dash of x, first derivative of sine x, and second derivative of double dash of x at x is equal to pi, and he is asking us to take step size h is equal to pi by 4 using forward difference, backward difference, center difference approximation. Also he is asking to find a true error in each case. So now before starting, what is the true value of the derivative of this f of x, first derivative and second derivative? So we will see solution. So f of x is equal to sine x, first derivative dy by dx, that is f dash of x, derivative of sine x is cos x, the derivative of sine x is cos x, and derivative of sine x is cos x. And if we again differentiate, then we get second derivative of double dash of x, then the derivative of cos x is minus sine x. Now if we substitute x is equal to pi, then if we substitute x is equal to pi, then f dash of x we get as cos of pi. Cos of pi is nothing but minus 1. And whereas if we substitute x is equal to pi in second derivative, then f double dash of x is equal to minus sine pi. Sine pi is again 1, minus sine is there, therefore it is minus 1. That is nothing but true value of f dash of x is equal to minus 1, and true value of f double dash of x is also minus 1 at x is equal to pi. So this is a direct differentiation that we can find direct differentiation. From this direct differentiation we get the first derivative and second derivative. Now let us apply this forward difference, backward difference, center difference approximations to find the approximations, first derivative and second derivative. So now now we know true value of first derivative and second derivative as minus 1 itself. In both the cases it is minus 1. So now to simplify this, we will start with xi is equal to pi, and we know h value as pi by 4. So xi minus 1 is equal to pi minus pi by 4. Pi minus pi by 4, that is nothing but 4 pi minus 5, 3 pi by 4. This works out to be 3 pi by 4, and xi plus 1 is equal to pi plus of pi by 4, and if we simplify it works out to be 5 pi by 4. 5 pi by 4, pi 3 pi by 4. Now to find this first derivative, so we know these values. and we can find out first derivative, second derivative using forward difference formula, backward difference formula, and center difference formula for both. So this is first derivative we find. In this case, first derivative, so we'll have formula for first derivative. So first, forward difference approximation. So before finding forward difference approximation, we'll find out f of xi minus 1, that is f of xi minus 1 means f of x value, which is sin x. So if we substitute xi minus 1 is 3 pi by 4, that is sin 3 pi by 4, then we get this as sin 3 into pi divided by 4. So this is going to be 0.707106. Then f of xi, that is nothing but sin x. F of x is equal to sin x. So x value is pi, sin pi. We get sin pi as 0. So this value is going to be 0. And f of xi minus 1, that is sin x value we are substituting as 5 pi by 4. Sin 5 into pi divided by 4. So this works out as minus 0.707106. So now we know the material that is required for us, and from this we can use various formulas: forward difference formula, backward difference formula, then center difference formula for finding first derivative. So for forward difference approximation of the first derivative, forward difference approximation of the first derivative f dash of xi, which is given as f of xi plus 1 minus f of xi divided by h, or we can say h. So f of xi plus 1 is minus 0.707106 minus of f of xi. F of xi value is 0 divided by h. H value is pi by 4. So this works out as minus 0.707106 into 4 divided by pi. This is going to be minus 0.9003. Now to find out relative error, true error, so true value which is known to us is minus 1. So first derivative value is -1 and true value is -1. So but by this numerical method we obtained it as -0.909. So true value is -1 minus of -0.9003 divided by true value is -1. So into 100. This gives us percentage true error into -1 plus of -1 divided by -1 into 100. This is the error is 9.96%. It is approximately 10%. True error is 10%. So for forward difference approximation, then we go for backward difference approximation of the first derivative. So formula for backward difference is f dash of xi is equal to f of xi minus f of xi minus 1 divided by eh. So again f of xi we know that is 0 minus of f of xi minus 1 is 0.707106 divided by h is pi by 4. Again this works out again as minus 0.9003. So again this true error in this case also is going to become 9.96% itself, because the values are same, therefore the true error is going to be same. Then moving to the third method, that is centered difference approximation of first derivative. Centered difference approximation of the first derivative. F dash of x I, that is equal to f of xi plus 1 minus f of xi minus 1 divided by 2h. So f of xi plus 1 is minus 0.707106 minus of f of xi minus 1 is again 0.707106 divided by 2 into h is pi by 4. So again this works out as minus 0.707106 into 2 divided by 2 into 4 divided by 5. Again this is going to be same, that is minus 0.9003. again true error is going to be same, that is 9.96. in all three cases if we see, the true error is 9.96 and the derivative first derivative is minus 9.003. So now moving to second derivative, So to find out the second derivative, so first of all, what we need to find out second derivative, that we will see here. So to find out second derivative, f of xi plus 1 xi plus 2, f of xi minus 1 xi minus 2. So we have to find out the values for two stages. So first of all, we'll see here xi is pi, xi minus 1 we know, xi plus 1 we know, xi minus 2, xi plus 2 we have to find. So f of is here xi is equal to pi, and xi plus 1 is equal to 5 pi by 4, and xi plus 2 is equal to 5 pi by 4 plus of pi by 4, that is going to be 6 pi by 4. 6 pi by 4 is nothing but 3 pi by 2. 3 pi by 2. So now xi minus 1 is equal to 3 pi by 4, and xi minus of 2, which is equal to 3 pi by 4 minus pi by 4. So minus pi by 4 means this is going to be 2 pi by 4, or that is pi by 2. So now we'll find out f of xi minus 2, which is nothing but sine pi by 2. Sine pi by 2, sine 90 is equal to 1. Sine pi by 2 is 1. Sine pi by 2 is 1. Then f of xi minus 1 is equal to sine, so 3 pi by 4. 3 pi by 4, already we have obtained 3 pi by 4 as, that is 0.70716 106. Then f of xi, also we obtained sine pi, that sine pi is nothing but 0. Then f of xi plus 1, which is nothing but sine 5 pi by 4, and this we obtained as minus 0.707106. Then f of xi plus 2 is equal to sine 3 pi by 2, sine 3 pi by 2, sine 3 into pi divided by 2 minus 1. This is going to be minus 1. So now we know this data, and then from this data we can find out the second derivative using different formulas. So first, second forward finite divided difference. So first we find out second forward finite divided difference. Formula. So this formula is f double dash of xi is equal to f of xi plus 2 minus 2 f of xi plus 1 plus of f of xi divided by h square. So this is nothing but f of xi plus 2 is minus 1. Minus 1 minus of 2 into f of xi plus 1. Xi plus 1 is minus 0.707106. Then plus of f of xi is 0 divided by h value is pi by 4 square. So on simplification we get it as minus 1 minus of 2 into minus 0.707106 divided by pi divided by 4 square. This is going to be 0.67149. Let us verify this answer once again. Minus 1 plus of 2 into 0.707106 divided by pi divided by 4 bracket then square. Okay, 0.67149 is this derivative. Then true error, if we want to find out true error, true value is again second derivative is also minus 1 minus of minus 0.67149 divided by minus 1 into 100. So this error will be minus of 1 divided by minus 1 into 100. That is, the error is 167%. 167%. 14%. True value minus of approximate value divided by true value. True value is minus 1. So therefore, this will be 1 point minus of 1.67149 divided by minus 1. That is 1.61 into 100. 167% error. So that is error is very large. Then if we move to this second formula, that is second backward finite divided difference. Second backward finite divided difference. Then f double dash of x I is given as f of x I minus 2 f of x I minus 1 plus of f of x I minus 2 divided by h square. So f of x I value is 0. we can see here f of xi value is 0. So here this is first is 0 minus 2 into f of xi minus 1. F of xi minus 1 is 0.707. 0.707106 plus of f of xi minus 2. F of xi minus 2 is 1. So plus 1 divided by h square. H value is pi by 4 square. So this works out as 1 minus 2 into 0.707106 divided by pi by 4 square. Again this is going to be minus 0.67149. Again true error in this case is going to be 167% because answers are going to be same. So this was minus this was plus minus. Okay, so again this error is going to be 1 minus 1 minus of minus, that is 0.67149 whole divided by minus 1 into 100. So this error is going to be 2 minus 1 divided by minus 1 means minus of 1 divided by minus 1. So error here is going to be 32%, 32.85%. In this case this answer is negative. Earlier it was positive, so here it was positive, so the error was 167%, and here answer is negative, so therefore error is 32%. Now moving to third formula, that is second central finite divided difference. Second central finite divided difference. This formula is like this: f double dash of x is equal to f of xi plus 1 minus 2f of xi plus of f of xi minus 1 divided by h square. So f of xi plus 1, f of xi plus 1 is minus 0.707, minus, it is minus, this is the value xi plus 1, so it is minus, I think it is minus. Okay, so minus 0.707106 minus of 2 into 0. So f of xi value is 0. You can see here f of xi value is 0. Then plus of f of xi minus 1. F of xi minus 1 value is, f of xi minus 1 is 0.707 plus, so plus 0.707106 whole divided by h square means pi by 4 square. So here this is going to become 0, this and this gets cancelled, it becomes 0, so answer is going to be 0. So here error is 100%, that is 200% error we can get here. So true error is equal to minus 1 minus of 0 divided by minus 1 into 100. So this is going to be minus minus 1. 1 means 100% error. 100% error we are going to get in this case. So this is how we are going to find out the numerical differentiation. So to have more accurate results, we must have the h value as much smaller as possible. So here it was pi by 4. So as it was pi by 4, we obtained this as error as very high. If h value if we take instead of pi by 4, earlier we have taken pi by 4, if we take pi by 8, then we may get second divided difference for second derivative more accurate or very close to minus 1. So let us check it by taking h is equal to pi by 8 and only one formula, that is backward second backward finite divided difference formula we will be using. So here xi is equal to pi we take, and in the backward difference formula what we need is xi minus 1 xi minus 2. So xi minus 1 xi minus 2. So pi minus of pi by 8, that is 8 minus 1 7 pi by 8, 8 minus 1 7 pi by 8, that is 7 pi by 8 minus again pi by 8. This is going to be 6 pi by 8. Now f of xi, that is sine pi, is 0. Then f of xi minus 1, that is sine 7 pi by 8, sine 7 pi by 8. This is going to be 0.3826, and f of xi minus 2 is sine 6 pi by 8. 6 pi by 8, it is sine 6 pi divided by 8. So this is going to be 0.707106. So now this we are using backward divided difference formula. So backward divided difference formula we write here as f double dash of xi is equal to f of xi minus 2 f of xi minus 1 plus of f of xi minus 2 divided by h square. So f of xi value is 0, minus 2 into f of xi minus 1 is 0.3826 plus of xi minus 2 is 0.707106 divided by h value is pi by 8 square. So on simplification we get it as 0.707106 minus 2 into 3826, 0.3826 divided by So this is going to be 0. Second derivative is going to be 0 here. Again error exists. So again here error is going to be 100%. Okay. Now we'll move to the next numerical. There we'll verify again these things. Now we have this function f of x as x square log x. So f dash of x, first derivative, is first function as it is x square, derivative of second function is 1 by x, then plus second function as it is log x, and derivative of first function as 2x. Again f double dash of x, second derivative, first function as it is x square, derivative of 1 over x is minus 1 by x square, then plus of second function as it is 1 by x and into derivative of first function is 2x. Then for second term, so this is the derivative of first. This was not necessary, I think. Just a minute. First we simplify this, just we simplify and then we proceed. So x square gets cancelled, so x x log x. So this is f dash of x. After simplification we get then f double dash of x, derivative of first function, derivative of x is 1, then plus 2 as it is constant, first function as it is, derivative of second function is 1 over x, plus the first function, derivative of second function, then second function as it is, derivative of first function is 1, that is log x. On simplification, this f double dash of x we get as 1, this x gets cancelled, 1 plus 2, that is 1 plus 2 plus of 2 log x, that is 3 plus 2 log x. So this is f double dash of x. So now this x value is given as 5. At 5 we want to find out first derivative. So f dash of x, that is at x is equal to 5, we get 5 plus 2 into 5 log of log to the base e, to the base e, log 5. Then we get this as 5 plus of 10 into log log 5. This is going to be 21.0 1.094. So remember that this is natural log. We have taken it as natural log. 5 into 5 plus 10, natural log of 5 is 20. Then here f double dash of x, that is 3 plus 2 log 5 to the base e. So this is going to be plus of 2 into 0 log of 5. So this is going to be 0.21 8. So this is true value, first derivative true value, this is true value. Now we proceed for various things. Here already he has given h is equal to 0.5. So we will find out all the values with h is equal to 0.5, and then we start with forward divided difference, then backward divided difference, and center divided difference for both. So first derivative is 21.094 and second derivative is 6.2188. So now xi value we take as 5, xi minus 1, and xi minus 2, xi plus 1, xi plus 2. So we can see here xi, h is 0.5. So 0.5 minus, then we will get 4.5 and here 4. And 0.5 plus means 5.5 and here we get. So f of xi minus 2, f of x value is given as x square log x, x square log x. So if we substitute 4, then 4 square log to the base e 4. So then we get this as this as 22.180. Then f of xi minus 1 in x square log x. So x value is 4.5. 4.5 square log base e 4.5. 4.5 square into log 4.5 into 30.45. So then f of xi, that is x square log of x. So 5 square log of 5, that is 5 into natural of 5, that is 40. Then f of xi plus 1, x square log x log to the base. Then this is 5.5 square log base to 5.5. Then we get this as 5.5 square into log of 5.5. This is 51.568. Then f of xi plus 2, again x square log to the base ex, this 6, the 6 square log to the base e to be 64.503. So we obtained all this information. This information will help us to find out first derivative, second derivative. So first derivative already which we have obtained by direct method is 21.094 and second derivative 6.2118. So now we'll find out first derivative f dash of x using forward difference formula, that is equal to f of xi plus 1 minus of f of xi divided by pH. F of xi plus 1 is 51 is minus f of xi is 40 5, which value is point. So this is going to be so this error, true error for first difference, which method we will use? This is forward difference. Forward, that's first order. The true value which is obtained here is 21.094. 21.09 minus of 22.66 divided by true value is 21.09 into 100. At that time, the value is going to be So then use backward difference formula, that is equal to backward difference formula is given as f of xi plus f of I minus 1 divided by h. Of xi value is 40.235 minus of f of xi minus 1 is 30.457 divided by h value is again 0.5. So this is going to be 40.235 minus 0.457 divided by 0.5. This is going to be 90.55. So true error confirmed. True value is 21.094 minus 19.55 divided by 21.094 into 100. So 2. Error is going to be 7.29%. The earlier value was 22, which was higher. Second value is lower. So again error is 7.29%. Now we will move to the center divided difference formula. The center divided difference formula. Now we can write this formula as f dash of xi equal to f of xi plus 1 minus f of xi minus 1 divided by pH. So f of xi plus 1, f of xi plus 1 is 51.568. 51.568 minus xi minus 1, I minus 1, 30.457, 30.457 divided by pH. 2 into 0.5 means 1. So this is 51.568 minus 30.457. So this is going to be 21.111. So true error we can find here. True error, so true value which is obtained is 21.094. 21.094 minus 21.11 divided by 21.094 into 100. So we get true error as 8%. This is center difference formula. Center difference formula. So if we use center difference formula, here it is minimum. Previous case we can see here there was 7.4579, whereas center divided difference formula what there was 0.08%. Now let us proceed for second derivative. So to find out second derivative again, using forward difference formula, backward difference formula. So first we use f double dash of x I, which is equal to f of x I plus 2 minus 2 f of x I plus 1 plus of f of x I divided by h square. F of x I plus 2 is 64.503. 64.503 minus 2, f of x I plus 1. F of x I plus 1 is 51.568. 1.568. And plus f of x I. F of x I is 40.3235. 40.235. 40.35. 4 divided by h square. H value is 0.5. 0.5 square. So on simplification, this we get as minus 2 1.568 plus 64.503 plus 40.835 divided by 0.5 square. So this is going to be 0.408. So the true value which we obtained by direct differentiation is 6.2188. 6.2188. So true error 6.2188 minus 6.408. So this is obtained by forward difference. Second derivative obtained by forward difference divided by 0.2188 into 100. So we get error here. We have for second derivative. It is 3.04%. So this is second derivative. So the second derivative we got here as 3.04 when we used forward difference formula. Then we use backward difference formula for obtaining second derivative. So f double dash of x I is f of x I minus f of x I minus 1 plus f of x I minus 2 divided by h square. So again f of x I value is f of x I 40.235. 40.235 5 minus 2 into f of x I minus 1. I minus 1 is 30.457. 30.457 plus of xi minus 2 is 22.18. 22.18 divided by h square. H value is 0.5. So this is going to be this backward difference form. Second derivative. So here we got answer as 6.004. So through here we can find as 6.2188 minus of 6.004 divided by 0.2188. So 6.2188 is 2 into 100. So then we get it as error is going to be 3.45%. 3.45%. So in previous case it was error was 3.04, but in this higher. Now we go for center difference formula f double dash of x, right? For second derivative. So this is for second derivative. F of xi plus 1 minus 2 f of xi plus f of xi minus 1 divided by h square. So we can see here f of xi plus 1. F of xi plus 1 is 51.568. 1.562 f of xi is 40.235 plus f of xi minus 1. F of xi minus 1 is 30.457. 30.457 whole divided by h square is 0.5. Plus 30.457 plus 51.568 divided by 5 square, and we get this as 0.22. Here is equal to 0.2188 minus 0.22 divided by 0.2188 into 100. So this error will be 0.01%. It is 0.019%. Is the minimum error which we had obtained by direct differentiation. This was also by center difference formula. Using center difference formula for finding second derivative, we got it as 6.2. So that is nothing but it is not necessary for us to know. This is very important, that it is not necessary for us to know this differentiation or this. So this we have done to know the error. So to know error, we must have the true value. So to find out true value, we have differentiated and then we obtain these two values. But if it is given in this problem that f dash of x is equal to 21.094 and f double dash of x is 6.188, then find the true error. At that time we need not do this work on this first page whatever we have done. So the true values are not given, therefore we have differentiated, and by differentiating we obtained the first derivative and second derivative in order to find out the true error here. So to find out true error we must know true value. So to know true value we have differentiated, but this is the value which we obtained by numerical differentiation. So by numerical differentiation, first derivative in this case is 22.66. So here it was 19.56. Then we obtained error 7.45 in order to compare which difference formula, whether backward, forward or center difference formula yields the accurate value. So here we have seen as the error is lowest in center difference formula. In center difference formula, error to find out first derivative as well as second derivative, you can see here error is minimum. So this is minimum error. So to have the minimum error, there are two things to be concentrated. So one thing is as far as possible use center divided difference formula, and the value of h should be if it is minimum, then the differentiation or derivative which we obtain will be more accurate. So with lowest value of h and using center difference formula, we can get more accurate results compared to all other things. So here we stop and we will discuss details class.